Lesson 5-2, Weight and Gravity. For bodies, that means something bigger than a particle. We'd have to use calculus to find the center of mass. However, to estimate precisely, we're going to assume our bodies are particles based on the center of mass, and for spheres, we're going to assume they're particles located at their center. So what is the gravitational attraction between a 75-kilogram boy and the 50-kilogram girl that's seated 1 meter away at the next desk? All right, so force of gravity is G-M-M over R squared. G is 6.673 times 10 to the negative 11 Newton meter squared per kilogram squared. Our masses are 75 kilograms and 50 kilograms. And the R is 1 meter. Don't forget to square it. The most common issue students have is they forget to square that. And we end up with 2.50 times 10 to the negative 7 newtons. So that's 1/10,000,000th of an apple. Or 2.6 times 10 to the negative 8 pounds of force. So I would say that gravity is not the reason why you're attracted to the person next to you. Since weight is the force of gravity, our weight then equal GMM over R squared. But we were calculating weight by mg. So if I make those equal to each other, the little m's would cancel out, and so the acceleration due to gravity is gm over r squared, where m is the mass of the Earth, or the center of whatever was providing the gravity for the weight. And r is usually the radius of the Earth, so when you plug in all that, g is 9.8 meters per second squared. Find the acceleration due to gravity at the altitude of the International Space Station, 417.5 kilometers above the Earth. Well, first of all, we're going to need the radius. So here's the Earth, and then here's the ISS. That's 417.5 kilometers. But we also have the radius of the Earth. So our R is going to be 417.5 times 10 to the third meters, plus the radius of the Earth, which is 6.38 times 10 to the sixth meters, which would be 6.7975 times 10 to the sixth meters. All right, so if I want to find the acceleration due to gravity, it is gm over r squared. G is 6.673 times 10 to the negative 11 Newton meter squared per kilogram squared. Our mass, that would be the mass of the Earth, 5.98 times 10 to the 24 kilograms. And then our distance was 6.7975 times 10 to the sixth meters. Don't forget to square that. And you end up with 8.64 meters per second squared. So when you're out in space, it's not that there's no gravity, because there's still gravity. It is a little bit smaller than our regular 9.8, but not that much smaller. So why do they seem weightless? That'll be for another lesson. How does the gravity from the moon and the sun affect us? It causes the tides in the ocean. Water is pulled in the direction of the moon and the sun. The gravitational pull from satellites will cause the main body to move slightly. So the moon causes the Earth to move. Planets cause the sun or star to move. That's one way where astronomers have decided that there are planets around other suns, as they could see the star wiggle slightly over time as some large planet went around it.